Welcome back to the Lehigh Carbon Community College Science in Motion Part 2 of Using Graphical Analysis Pro. What we'd like to be able to do is to provide you with service that will allow you to use this with yourself and your students and be able to share data virtually that they can then analyze that along the way. Basically, the graphical analysis app itself is free, and you can download that for any device that you own by choosing the right platform. Just go to vernier.com and look for downloads, and you'll be able to see that which one would fit your particular device. Once you have done that, to unlock the features that are associated with the Pro, we will give you access to a license code. Right now, we have it partially obstructed because we don't want to have this open to the public. It's a pay for subscription. Our subscription goes until June 2021, the end of June. So we will share it with you, and then you can share it securely with your students so that it's only to be used within the classroom and your students themselves. The licensing key, if they don't have graphical analysis on, they'll download that first. Initially, it will show up with a shield with a check mark, and that's where they would click on that shield, and it would ask them to put in the license key that would give them full access. There's also a trial version that they can get for 2 weeks at any time, and that will expire, of course, after 2 weeks, and they'd have to renew it if they would keep going through there. But through our program, Science in Motion, you'll be able to have that for later on. Um, Graphical analysis will allow you to save your data as a .gambl file at the end of it as a suffix naming. The earlier versions was just a .ambl for graphical analysis, but you can open either versions of those, the GAMBL or AMBL, using the new graphical analysis setup. Any of the labs that we're going to be looking at and any of the experiments that are listed as part of the Graphical Analysis Pro will be able to be downloaded if you create an account at vernier.com and then go to your downloads. It will let you see what you have access to. For other experiments, we are going to be taking a look at using other data from books that aren't included in the Pro at this point, but we have purchased almost all of the Vernier books, which you can then get copies of the student version and the teacher version by requesting that on our particular website. Our website for Science in Motion and being able to get the answer key that goes along with any of the labs that we're going to be looking at are going to be at our site. Sorry. So it's lcc.edu/academics/science and engineering/science in motion. It used to be lcc.edu/sim, but it's now gotten further buried into the website. So if you bookmark that, you'll be able to find it more easily. But in there is a request form that will let you say that you'd like to have the pro subscriptions that you could use with your students. This is just one of the things that we offer. There's also looking at Pivot Interactive's subscriptions where you have high-speed videos that you can work with, as well as almost all the labs, over 450 different labs that you could choose from to either get virtual help with, or if you're still doing in-person classrooms, you can borrow equipment or get support to be able to use that equipment as well. The Vernier site has a list of other data that they offer. We'd like to take a look at that so that you can see what your options are. And this is the Science in Motion website. When you get to that, this is the first page, and right there it says online request form. You click on that. Over here on the side, it shows you other things that we've been busy creating during this online learning time, free online educational activities, and so on. You can explore that and see what's there. But in terms of the Vernier people, they have been offering a lot of different remote solutions. So the one that we're doing right now is using graphical analysis and exploring data. And when you click on browsing their library, you will see that it's not just evaporation and chemistry, but there are multiple labs that are being presented. And some of them are for advanced classes like advanced biology, and some of them are for middle school and even elementary school. So you can pick and choose which particular labs you'd like to look at. And then each one of those has some kind of data set that was generated that goes along with that. And some of them have a YouTube video that describes how to set it up and the procedure that is used for that individual experiment itself. For example, we were looking at chemistry, experiment number 9. So if I click on the tab for chemistry, there's advanced chemistry, there's organic chemistry, there's um, looking at chemistry for the AP classroom, electrochemistry, and so on. So there's a variety of topics. But if you click on evaporation of alcohol experiment number 9, CWV number 9, what that will do is it'll take you to a Google link where you can then download the folder. So you want to go and download the entire folder at one time, which will give you a data file, an AMBL file. That'll be the one copy. And it'll give you also a Word file that you can download. That will be the experiment itself. So that's where you get that information. I've already zipped it. Comes as a zip file when you open it up. It creates that as a folder. When you click on there, you have either of those two that you can work with. Now, I mentioned that these are editable files, so you could change that and modify it. So what I did for one of my experiments is that I went beyond the alcohol evaporation, beyond looking at pentane and hexane, and I edited it to include other organic substances. So I'm going to go to evaporation and intermolecular forces, and this is just adapted from the Vernier experiment number 9. So I just changed it, edited it a little bit, condensed some of the pages, and we're going to use multiple different liquids. One of the things I changed is I shortened up the time. You might recall that they were 240 seconds. I made it 180. Doesn't sound like a lot, but when you do it 10 times, that's 10 minutes of your life that you've saved. But the same idea, I was only doing one evaporation at a time to get differences just as an individual sample of the liquid, and talked about how they could use the linear fit where it's most straight during the cooling portion before it starts to level off, and then how would they process the data. One of the things in the AP course is that they like to look at particulate diagrams. So there's a question that I threw in there about trying to diagram how water molecules are held together by hydrogen bonding. Or there's also looking at Lewis structures where they have to be able to figure out octets beyond the octet structure. So PF5, how does phosphorus use all 5 of its electrons to bond to fluorine atoms? And then from that, how would you predict what kind of strength of attractions it would have, and use boiling points as a gauge? They can actually cheat and look those up and go from there, but that gives you the idea of what's involved in that process. On my graphical analysis, what I would do is I would say that I want to not see experiments because those are only the ones that have already been formatted and set up for the pro, but I can go to choose a file. And what I have done is over the years as I've collected data, I just keep putting it into a lab data file. So I took the organics lab, the evaporation of organics, and it's actually evaporation of organics number 2. So when I open that up, what I see displayed over here is both a graph and a data table. So as I go across here, I will see that I have multiple different liquids. Not only did I use 1 propanol, but I also used 2 propanol, commonly known as isopropyl alcohol. And we also looked at acetone and threw that into the mix. So all of that data is over here under the y-axis. you'll see that you have just extra liquids that you can work with. I can change the display that I'm showing up here at the top. And by clicking on this box, I can say that I don't need a data table. I just want to see the graph. What I'm also going to do is that I hooked up my phone like I did before. So let me just drag this over so it's out of the way. And I'm going to connect. I have to turn on the broadcast. So start the session. And it's going to give me what's going to be the code that I want to put in to gain access to it. So that was under data sharing. And my code now is SSZ 9XC. So I should be able to connect to that same data. Now, initially, there's nothing over here as far as any data sets because I have not run the trial yet. It's just set it up as a blank format. If I go back here and I go, collection and look at the setup of the data, it shows you that this is the cooling curve when I first did it with water. So it's going to take a while. I don't have it at, 4x speed because this was just collected by looking at raw data. So I don't have that option to format it. But what I want to see is what am I getting on my student version? So over here, do I have anything that's now listed? If I click on the y-axis of my phone, where I'm running the mirrored version of the graphical analysis, now all of this data shows up. So if I want to see water at the same time, nothing's going to show up initially because you may notice that the y-axis and x-axis also have to be formatted. Right now, those are not highlighted as the columns that are going to be displayed. I have the option, since this is a new data table, I can put either one on the X or the Y. But I want my temperature on the Y-axis, and then down here on the X-axis, I want my time value, and now the water appears in terms of my setup. I could have done that also by going over here and clicking on, another liquid, and working with that, and changing that so I'd have other liquids in comparison to that. My students are now on their own since they have that data, so they are going to have to process all of those. So they might do an experiment where I want to say, how does water compare to the methanol? And that would give me my data. If I want to recall how to add a legend onto it, now for my individual data, I went back and changed it from, data set 1, data set 2, or temperature 1 and temperature 2, and actually identified what it was. So the blue one is your methanol, and the red one is your water in terms of your setup. If I do the same thing over here on my graph and look at adding a legend, I will see that the blue one is pentane, and then the green one on mine is hexane, and the red one is water. So the colors might change, but the coding will match up to the correct liquids as far as how they will apply. So now the students have the data. They can go through and do the same thing we did before: statistical analysis, graphical analysis. They can add annotations onto the curve. You can have them do a prediction where they would say, what do you think it would be like if you now took in something like octane? Where would that fall on the scale? And let them draw a prediction. So where does the octane fall? Well, it's probably not going to go down as fast as the pentane, which has 5 carbons, and then fill that in with hydrogens, that would have 12, or octane, which would have 8 carbons, and then you look at 18 hydrogens on there. I think it's going to fall somewhere in between. So maybe it's going to be right here in that setup. So if I actually had some octane, I could test it and see how that would match.